So I'm going to get things started today by talking to you about some work that I've been doing focused on viral mapping, and now I'm sort of thinking more broadly about social mapping, not necessarily viral maps, but just maps that appear on social media, where they come from. And specifically, I'm going to talk about disinformation in some of these mapping formats and some tools that we can build and work with to try to understand them and their origins. So I'll begin by describing a little bit about what motivates this work, some examples that have drawn me to this topic, and my co-author, Shi Zhu. So Shi Zhu is my co-presenter today. He's not here because America is hard for visas, and it's really deeply unfortunate, but he's a postdoc in GeoVista Center who's been working on some pretty cool stuff with me on this. I'll talk then about, after motivating this project, some tools that Shi has been building to visualize social maps and their derivatives, and then wrap up at the very end with a little bit about what can come next. So to begin with, I want to take a little step back here and think about social cartography writ large and kind of where some of these maps come from. I'm inspired by examples like these where maybe through tweets or through things on Reddit or other sources, in some cases we have maps that go viral that are really popular, where we can understand right away that they are original works. Like if Nate Silver posts something from 538, or the New York Times puts something up, we understand their provenance and we understand that it's probably new stuff. In other cases, and this is like a sort of co-located example I talked a little bit about last year, there are maps that kind of come off of those things or might be inspired by some of those original works where the provenance is way less understood. In this case, this was a tweet by someone who has a little verified check mark, but this is not actually their map. And it took a long time for me to figure out who the person was who actually made the original thing. In more contemporary examples, we have some things that maybe are a little bit more obvious, where we have original works and then maybe known modifications of those works. And so I would like to think about, like, how do we diagnose these things in the digital realm? In this case, this is more physical. And as a very, very brief aside, if you want to know how little tiny Sharpies end up at NASIS, this is Ken and I bantering back on DMs about, like, can we order a large amount of Sharpies that say cartography pen on the side? We should, yes, we can. And then a few months later, here you go. So that's a little digression from my interest in this project, and what Shi and I have been working on are like, where do social maps come from? Some of these things are really obvious and some of them are really not. So we've been exploring with various machine learning methods and sort of image label recognition, web entity detection. But in the last few months, we've been really focusing on reverse image search as a possible mechanism for understanding where some bits and pieces come from. And I showed this example here last year. This was one where I really had to try to explore to figure out who made this thing. And we found along the way through things like platforms like TinEye that you can find partial matches to images quite easily today. So we're applying that to maps, essentially. That's what we're doing in this project. And maybe we can do this with like a really large number of examples. That's kind of the goal. I was really interested in the fact that there was one of these that just was somebody else asking a question. Does anybody know where this thing came from? I think as cartographers, we have this question immediately about some of these products, like, is that data legitimate? Is that a modification of something that somebody else made? Maybe I just want the data from it, right? We're just sort of needy about that. So I want to show you some examples of a tool we built called MapReverse, which is it's research grade software, so keep that in mind. But we're evolving it pretty quickly, and MapReverse is a platform that we're developing to take both image reverse search algorithmic services, as well as sort of web entity detection and label detection, and kind of pull them together, seed it with a viral map or social map example, and then explore maybe where it came from. Like, is that a new thing on the internet, right? That's kind of a fundamental question to ask. And if it's not, like, what are some of its like cousins in terms of the digital realm? So the architecture of this system is not super complicated. There's a visualization client that's using various JavaScript libraries, HTML5, JavaScript. And on the server side, we're using both what you might consider computer vision and reverse image search algorithms. Specifically, we're currently using Google Cloud Vision and TinEye image search APIs. We have plans also to work with Amazon Rekognition and Bing Image Search. Those are some other commercial services. You could certainly roll your own stuff. There's a lot of people doing things with Markov chains. I'm not that guy. So I would like to work with people that might be those folks and help out with this project, we can't do that to people. So let's look at a little bit of examples here. All right, this is the fun part. Some of you may have seen this map recently. So the question I have about this that's research oriented is like, well, where did that come from? Because I'm gonna speculate that Lara Trump is not a cartographer. If I'm wrong, then I owe her an apology, and I will write that with a Sharpie. So I want to show you a tool. This is MapReverse live right now. We'll see if it's actually going to work. The Wi-Fi here is awesome. This happens. There's a lot of people hitting it at once. So what we've got here, I'll just walk you through the views here. MapReverse has sort of a big matrix up here that's ordered by similarity. So this is TinEye's similarity measure, and if I scroll down here, you start to see that the maps start to turn into all kinds of other things that are maybe a little bit visually similar, but are clearly sort of distinct, distant cousins. There's lots of different sizes of images in some of these things, but you can start to diagnose maybe where these different images come from. You can also see where people have modified even the viral original, so to speak, and have added bits and pieces to it. Fox News likes to put like flags and stuff next to them in news articles. In other cases, there's like stock images that don't make any sense that are also in this collection. What we can do with this platform at the moment, we can play around with the similarity score. So the little band of color, it's going to be hard to see on screen here, but this little band of purple there, that's like a more similar to the original image, right? This is a measurement here. This is coming from TinEye, so we don't know how that's really based. We can do some filtering and filter out some of the low similarity objects and kind of focus on the ones that are of high degree of similarity. A lot of them are like this, they're just modifications. But then we found something that's kind of interesting. So this is a much earlier predecessor. This comes from over a year ago, where it says behave or be extinct. So not impeach this, but behave or be extinct, which is a lovely, uplifting national message that we can all rally behind. And what a great time to be alive. This tool has also sort of helped us scare ourselves. Thinking about like the image itself, the original one, it appears to be a modification of the winner-take-all choropleth from 2016, in that a lot of the counties that Hillary won are not actually on it, so they made it redder. Somebody did that somewhere along the line, and we still haven't totally diagnosed that, where that image came from. So there's an interesting aspect of this that may be getting us closer to understanding like where exactly did this thing originate, and like how did that get made. Maybe Lara Trump is a cartographer. Other things that are happening in this window here that are complicated and a little bit inelegant at the moment. There's a timeline here. We can sort by example. So like these are older examples. This predates the image that in question by quite a few years. Here we've got some of these older ones as well. They've got little bits and pieces. This tree map down here shows web entities. These are kind of like the concepts and topics that Google Cloud Vision believes are associated with the image on the internet, sort of like the context on web pages. It's not a great interactive at the moment, but it's getting there. We have a kind of a crude list here of labels and entities as well. You can kind of hopefully see where this is going. So this is the static image in case it didn't work. Let's look at the Sharpie map. All right. So the Sharpie map is a really fun example too, because not surprisingly, there are a lot of other examples. In fact, if you start looking down through this list, these are all kinds of other hurricanes, right? There's lots and lots of patterns here. So this is a tough one to figure out. And this is where we need time. So we've got different peaks here, and these are previous year's hurricanes essentially down here at the bottom. But if we look up here at the most recent era, now we can start to figure out that like some of these are the actual Sharpie map that are brought in. I want to draw your attention to this little score here. So we're not entirely sure how TinEye, for example, decides that something is 29 similarities out of 100 to something else. It's not a percentage, it's some type of index. It's a black box algorithm, but I want to point out that this is a photograph of the Sharpie map, and it gets a relatively low similarity score to the original image, and I think that's in large part because it's a photograph of the image. It's not, so a direct bitmap that was modified would be much more algorithmically similar. So this is a real issue with like seeing something that we perceive as being very, very similar, a small modification that's very meaningful on the original, versus how we're going to have to deal with this in the world of like, if we're trying to detect these things automatically, it's going to fail miserably if someone just takes a picture of it and reposts it. That's going to be hard. You can fool it quite easily. All right. I want to show this example as well. I was pretty fascinated by this one. that we would be using model runs from some random flood district in Florida at the highest levels of the White House and giving it to the president. So let's see whether or not who's doing the fake news here. You can go back to the interface and click on this. So this is working pretty well. Cool. It appears to us that this image that the president tweeted, that's the first time that that specific image appeared on the internet. So the one that comes from is here, that was posted several days earlier. And those of you in the audience can probably see what you do to make that image. You just lower the brightness and amp up the contrast a little bit. So somebody might be a cartographer at the White House who played around with this. So there was a modification with a Sharpie, and then there was a modification with something that's not a Sharpie. And now you're all probably even more scared than you were before. One thing that's kind of cool about this is we can play around and see all the different URLs. These are domains that are associated with some of them. A lot of them are crazy. USAUKnews.com sure is a super reliable source. Some of them are familiar. Like this example doesn't have a lot of bad ones, but there are others where there are clearly like bot-generated websites that are scraping viral content and reposting that. So there's a lot of noise. There's also a huge challenge here with image hosting versus website hosting. So image hosts are often completely separate internet entities now than the actual website itself. And we get both kinds of URLs, and there's a lot of challenges with that in terms of reproducibility as well. A lot of these examples die, and relatively quickly. One last example I'll show you along those lines. This is one of my favorite kind of early viral maps at this point. This is a completely concocted fake thing from the 2011 Japan earthquake. That Google Earth design, Photoshop munged up plume thing there, that's not real at all. And the bottom right corner there is actually the tsunami propagation model that NOAA created. It has nothing to do with how radiation spreads around. That's not correct. I still don't know. The US NRC did not make this thing. That's not their logo. This is spread mostly via email and around the time. And if we play around with the example here, you'll see some of the limitations of image search. You can see that it's the timeline here. There's a lot of examples that are sort of just peppered around the web. It's not super consistent, and we can't reach back really far. However, we can get some really interesting derived images out of this. If you want to go to buffalohair-jag.com and ruin your computer, you're welcome to give it a shot. So there's a lot of, this is like the summary of this work, I guess, could be is lots of risky clicks. So in this case, actually, I don't know a lot more about where this came from, and a lot of the links are dead. If you try to go find the original images, they don't load. So the crawling that we can do even back just several years gets, the quality is very, very poor. So our ability to reach back and understand these things in context is actually kind of slipping away, I would argue, very quickly. All right. If you would like to try it now that I'm done demoing it, you can go to mapreverse.org. Like I said, it's research grade software, so it kind of works. There's some linked things about it that are kind of fun. You can filter different views. We're going to be adding a tag cloud at some point that's sortable by size and be able to change the matrix by time, for example, and make the similarity filter a two-way filter because that would be much more useful. Quite a lot of work that Shiju has put into this. He's looking for a job, so if you're interested in a fantastic computer scientist who understands geography, I'd like to help you connect with him. Okay. Last little thing here, I would say there's lots and lots of questions that come up with this. One of them for us is also to be able to compare different reverse image search methods. We didn't explore anything about sharing here. So there's all kinds of network information here about who shares what, how these different things filter around, and that's definitely the sort of next year or so for this project. All right, I have 1 minute left for a question to me. Okay. Thanks.